Hey guys, this is just a quick check-in on what the notes for today are. You just did section 2.2 on reasoning. Now we're going to do section 2.1. I'm going to kind of go backwards a little bit. 2.1, it's a little bit different. That's why I don't want to spend too much time on it, but I don't want to get down to something later on in the road and have to explain it now. So I'm going to try and explain it here with this video. I'm not going to be checking off notes, but I do want you to watch it and take notes on your own. So just get a couple of examples, get a couple ideas down in your notes for whatever the section is. It's about statements, okay? So again, I'm not checking off notes, but this is like your homework piece on your own. You are going to watch this video, all right, and make sure that you know kind of the gist of what it is, because we're going to see things like this later down on the road. Hello geometry, welcome. It is section 2.1. We're in mod 2 already, fantastic. Today we're going to talk about conditional statements. So different statements that you can make in geometry. We're going to start off with really basic examples and things that you may not even think are math, but eventually they're going to lead us there, all right? So have some patience and let's get started. Got a new learning target for today's notes. So learning target, I can write conditional statements and related conditional statements. I would just get that first one down. Some of these are from last year. I'm trying to adjust things for online. So just get that first part. I can write conditional statements, all right? Success criteria, understand basic postulates used to study geometry. We'll talk about that later as well. Write conditional statements for sure in the form if P then Q. We're going to see what that means exactly, all right? And then at the end, we're going to cover converse, inverse, and contrapositive statements, all right? So, just a little bit of vocab. When you make a conjecture, you're making a statement that you believe is true, all right? If you need to get that down, make a little note. What does conjecture mean? A statement that you believe to be true. For example, all right, I'm going to read this out for you real quick. A car salesman sold 5 used cars to 5 different couples. He noticed that each couple was under 30 years old. So it's a younger couple. They're buying used cars. The following day, he sold a new luxury car to a couple in their 60s. And the salesman determined that only younger couples buy used cars. So from this real-world example, we can make the conjecture that probably young people are the ones that are buying used cars. They haven't been saving up for years versus the couple in their 60s have been saving up for years. They've hit retirement. They have money that they can spend. All right. So car salesman, he makes this conjecture that from what he's seen so far, only used cars are being sold to younger couples. All right. It's a statement that he believes to be true, a conjecture. All right, we're going to roll on to some more vocabulary. We talked about conjectures. Now we're going to talk about conditional statements. Conditional statements can be written in the form if P, then Q. All right? So take a second and write that down. Get a little thing in your notes about if P, then Q is the form of conditional statements. What exactly do we mean when we say P and Q? We can write a sentence that says if something, then something, right? I mean, that's an if-then statement, but what does P and Q mean in terms of math here? P is the hypothesis, and Q is going to be the conclusion, all right? We're going to see some examples of this, so don't worry too much. P is your hypothesis, Q is the conclusion. So, if this happens, if P happens, your hypothesis, then I conclude that Q, my conclusion, is going to happen. All right, it's kind of convoluted, but get the general idea, all right? Again, things are usually going to be in the form if, then. Take a second, pause if you need to. P is the hypothesis, Q is the conclusion. That's what we're looking at when we're talking about conditional statements. All right, so we're back to this problem here where the little car salesman guy believes that he's only selling used cars to younger couples. This is our conjecture, something we believe to be true. Can we pull from this sentence can we pull a hypothesis and a conclusion and write it now as a conditional statement? So again, conditional statements are in the form if P, then Q. So I'm just going to write if and then. So here is my conditional statement. So if hypothesis, then conclusion. All right. So let's just say if the couple is young, if it's a young couple, then they're going to buy used cars. All right. Again, we have this hypothesis. A young couple walks into the car salesman place, and then they're probably going to buy a used car. I could also see it going the other way. If the car salesman sold, or excuse me, we could say if a couple buys a used car, then they're probably young, right? So I can see going both ways, all right? So we're just identifying a P and a Q. Okay. One more example. I would say, that last one was a big one. Don't worry about writing that one down. This would be a good example to get. Here is our conjecture. Students who passed the test studied their notes. I mean, as a teacher, I hope that is something that I believe to be true, right? If you pass the test, you probably studied your notes. A conjecture, all right? A statement that is believed to be true. So, can we write this conjecture as a conditional statement? Again, what's the hypothesis? What is the conclusion? So, I'm going to just write this as a conditional statement. We know that they're in the form if P, then Q. So, if something, then something, right? If you studied your notes, then my conclusion is you passed the test. And I could see it go the other way as well. If you passed the test, then I can conclude that you studied your notes. All right? So either way I think is fine. Go ahead and get one of those down. The other thing I want to talk about is negation. All right? If you see something that is being negated, I want you to think the opposite. I want you to think not. All right? So, negation, think not. The symbol for negation that I usually use looks like this. So if you are given a statement, let's say I've got P. This is my hypothesis. Then the negated form of P, again, I see that negation symbol and my statement. The negated form of P would be, well, my favorite color is not blue. All right. Again, here's your conjecture. Here is the negated conjecture. All right. So, again, just think opposite or the word not. Okay. We covered a lot here. So now we're going to talk about different forms of all of these. This is not something you need to get written down, like especially this middle column. Oh my gosh, don't do it. But I would say make sure you get these ideas of the types of statements we'll cover and the symbols, all right? So, a conditional statement. The definition says, again, don't worry about writing these down because we're going to get the symbols here in just a second. For a conditional statement, it's a statement that can be written in the form if P, then Q. Again, where P is the hypothesis and Q is the conclusion, all right? So here's the symbols. I'm going to make another column for Miss Blackman's symbols because I like to, again, use that special little knot, all right? So this is This is Miss Blackman symbols. So for a conditional statement, I like to say if P, then, I usually use an arrow for then, Q, all right? So that was conditional statement. We've seen examples of those before. The converse of this conditional statement would switch your hypothesis and your conclusion. So again, here is our conditional statement. If you studied your notes, then you passed the test. The converse would say, exchange your hypothesis and your conclusion. So, if Q, then P. All right. Again, if Q, then P. When we had the car salesman thing, and I said, if you're a young couple, then you buy used cars. And I also said, if you buy used cars, then you're a young couple. I was covering both the conditional and the converse there. Again, they are switched. If P, then Q, or your converse, if Q, then P. With your inverse, again, this is the next one down here. This is negating the hypothesis and conclusion of a conditional statement. So the inverse statement says, take this thing and negate everything in it. So it would be, if not P, then not Q. All right? So the inverse in symbols looks like, if not P, then not Q. And again, that's written out in words in here, all right? That's the inverse of a statement. The contrapositive. I know these are kind of fancy words, but we're going to be using these, all right, throughout the entire year. So I do want you to get a general idea of what these look like. The contrapositive says a statement formed by both exchanging and negating the conclusion and the hypothesis. So it says, if not Q, then not P. All right, so the contrapositive says switch your conclusion and hypothesis, kind of like what we did here in the converse, and then negate it. All right, so the contrapositive would be, if not Q, then not P. All right? So I want you to have some form of this chart. Maybe you get the statement name and the symbols, or you get the statement name and the shorthand version of it. Somehow have these written down in your notes, because if I give you a conditional statement, let's say, if Miss Blackman likes ice cream, then it's chocolate. Then I would ask you, what's the inverse of that statement? You would say, if Miss Blackman doesn't like ice cream, then it's probably not chocolate. Okay? So, that was it for today. Okay, so again, you don't have to check off notes. Don't come to Blackman 107. Just make sure you have an idea of what this section was talking about. Thank you guys. Have a great weekend.